Hi folks, Brian here. We're working on Chapter 3 in Mastering ArcGIS by Maribeth Price, 7th edition, and I'm demonstrating something that always gives students a little bit of trouble, how to georeference an outside image or raster and get it set up for a correct coordinate system. And the example given in the teaching tutorial is using National Weather Service imagery. And I've got that here. The first step to pay attention to, very important to success, is when you find an image that you like to georeference, make a good guess as to what coordinate system or projection it's in. In this one, we see distortion, we see the continental U.S. stretched out looking, and we see horizontal Canada USA boundary, which is a line of latitude. So those are all clues that tell us we're looking at a geographic coordinate system. Most likely it's going to be WGS 1984. That's going to be basically the same as NAD 1983 for the continental US. So either of those are what we want. And over here, I have already set up a window that we're going to use in ArcMap for georeferencing the image there. So let's zoom into it. And the first step to make sure that this is going to work is notice that we're in a projected coordinate system. Clues to that are no distortion of the shape compared to the other image, and we have a curved line of latitude along the northernmost boundary. So the first step for success will be changing this to this coordinate system for the data frame here to match what our incoming image is going to be in just a minute. So let's do that. Layers, properties, coordinate system. You can look for WGS by typing WGS up here. And that's not the one we want. Canada, no. We want world. We want, sorry, we're not going to be in projected coordinate systems. We're going to be in geographic coordinate systems. So world under geographic coordinate systems, WGS 94 is pretty safe choice if you suspect that you're dealing with a geographic coordinate system. So hit OK to that. You get a little warning message and instantly get a very ugly looking United States. Let's zoom out a level or two. Zoom back in. We want to make the map of the lower 48 as large as possible to match our image that we're about to georeference. So let's go to that, back to Chrome, and hit the full resolution version of the National Weather Service map. The more pixels you have, the bigger image you have, the better off things are going to be when you go to georeference that. So let's hit the full resolution version. It takes up a lot of screen. You can scroll around and see where weather is currently. What we're going to do is right-click to save this image. So right-click right on the image itself, save image as, and it'll only give you the choice to save it as a GIF file. Other sites will give you the choice of saving as JPEGs or maybe PNGs. Those are all acceptable formats for ArcMap. While I'm talking, I'm navigating to my folder and to my MGIS data folder, and I've created an imports folder that my students don't have. I always recommend using an imports folder to put stuff that you're getting off the internet until you've got it worked out. So I'm going to call that weather, and today's date is October 5th. To 2017. Weather October 5th, 2017. We could get a little more specific with the time, but that's good enough for now. So hit save, and when it finishes flashing down here, that's your clue that it saved it. So let's go find that thing in ArcMap. So I bring open my catalog window. I find my imports folder right here, and whoops, wrong spot, and imports folder in MGIS data, and there is the image that I just saved to my MGIS data imports folder, weather October 5th. I'm going to drag it to the image. Okay, you got a complaint here and another complaint here. You can safely send those away. Now, the process of geoprocessing is controlled by a toolbar, like many things in ArcMap. So we go to the Customize, Toolbars, Georeferencing toolbar, bring that up, and it knows, you see right here, that it knows that you should be working on weather October 5th, 2017. So to make this image, very important here, you make your extent zoomed in as closely as possible and as large as possible to match the image. And the first step to actually bring this in and start working on the georeferencing is hit Georeferencing menu, Fit to Display. And that attempts to match up the extent of the image that we just saved to our control image, our states. Okay, so to make that work better, we want to make states a little less obtrusive. We're going to use this, and I will hit States, Fill Color, turn that off. We want to be able to see through. And we want to make a big, fat, bold, prominent line. Let's do a red 2-point line for the state outline. That'll allow us to shift back and forth. And now the process is going to involve adding control points. And if you're careful about your control points and you started off with a good choice for your guess of coordinate system, you can normally make a pretty good run at it with just 4 control points. Again, being careful. And here careful means working diagonally across. So I'm going to start in the northwest and go to the southeast, and then go to the southwest and up to the northeast. And if all goes well, we will have a pretty good match of our image to the coordinate system. So let's zoom in to the northwest corner of Washington. There we are. And we're going to add control points. A very, very critical point here is that you always have to add your points in the same order. You can click on your control image, your states first, and then the image that you want to georeference second, or vice versa. But every control point you collect has to be in that same order. So I'm going to start with the image, and I'll start here in the northwesternmost tip of Washington. Click on the image, and it will show a line showing where we're trying to connect that to, and click on the vertex of our vector map of the lower 48. And right away you can see that we've gotten a big improvement in the fit of the map to of the image to our control map. So I hit the back button to go back to the full extent or the previous extent. Zoom in again. Let's go to Florida and try to make another pick of a couple of control points. Hit Add Control Points again. Again, image first is the order of things that I'm doing. So let's hit the Florida Keys here on the image. Click, and click on the equivalent place on the map of the lower 48. Click, and you can see we've shifted. We hit the back button, and we're already making good progress. You'd be tempted to quit now, but you actually need at least 4 control points in order for a valid georeferencing to take place. So back to zoom. Let's zoom to Southern California. You can see we're getting so good with our fit that it's going to be hard to find points that we can hit. But let's go ahead and go down here. We could probably find something to do down here now near the border with Mexico. So I click to add another control point. I'll click just here on the image. Again, image first, and then the vector map. I'll need to hit the back button a couple of times to get back to the full lower 48. Back to the zoom button. Let's go up to Maine, New England area. And this looks like a spot that needs a little bit of work. Let's touch up the boundary between the northernmost boundary between Maine and New Hampshire. Add another control point. Once more, clicking the image first, and then the map. Okay, so that's given us a little shift. We've done a pretty good job. Let's go back to the full extent of the lower 48, and visually it doesn't look too bad. You can check on the errors in your pics by going here, viewing View Link Table. The link table is what's used to evaluate the connection between the image to be referenced and your known image, in other words, our lower 48. And the key thing there is the residual numbers. And we've got some nice low residual numbers in the last column on the right here. So that's a pretty good fit. We've got nice low numbers. Visually it's good. It's certainly plenty good for a map of the entire lower 48. If you were working on a particular state here, like Washington or any of the states, you would want a little more detail, but we're probably just fine with things the way we are, and we're ready to save it. Now, there's no particular specific save mechanism. The image that we brought in from Weather Service already exists on disk. All we're doing is telling ArcMap what its coordinate system is. So that's here under the georeferencing menu, and there's nothing that looks like save. You just have to know to do this, and I'm telling you to do this. Go, when you're satisfied, go update georeferencing, and then that saves it. You're then ready to send this away, remove it. You can even start with a whole new blank data frame, and ArcMap will now know what the coordinate system is supposed to be when you bring in this image, and it will no longer complain. If you want to satisfy yourself as to that, right-click on it, hit Properties, and when it finishes thinking, it will show you information under the Source tab about the coordinate system, and it says it's in WGS 1984, which is what we used for the GeoRectify process, or georeference process. So to reiterate, a couple of key steps are: get your image as big as possible, make a reasonable guess what your image is in terms of the coordinate system it was based on, and then set your map data frame to be that same coordinate system. Work systematically in diagonals, northwest to southeast to southwest to northeast is what I did. Don't work in a small area first and then spread your way across the country. And also, in adding control points, click on the image first and then your known good map, or vice versa. But you always must do things, click on your points in the same order. All right, well, I hope that helps you, and let me know.